Azure. Then we go into the types of load balancers we have in Azure. We go through probably why we need a load balancer. We now have to decide what types of load balancer we want to use depending on the requirement. I actually have a tutorial probably after like 20 minutes of talking. We'll just build like 3 VMs and just try to configure a load balancer. So let's just go through this. So what the first thing we're going to look into is the design principle. So when we're designing for anything in the cloud or probably on-prem, we try to make it scalable. We have to make it reliable, efficient, and security. So those are the 4 principles we have in designing fundamentals. So what does scalability mean? So basically scalability is just that when we need to add something else, so like let's say our VM is 2 gig RAM and we need to scale it to 6 gig RAM because of whatever, we can actually just easily scale it. Reliability is just basically saying that when we need the resources, it's reliable, right? So it's available for us to actually use anytime we want to use it. Then efficiency is making sure that we are only paying for what we need. Because this efficiency actually comes because in the cloud, it's more of a OPEX, that's operational expenditure, than a CAPEX, capital expenditure. So previously in on-premises or like traditionally, like in your environment, you have to decide if we're going to get a server, we have to decide all those things. But in the cloud, we don't have to decide any other thing. All we just need is click, 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 and we have it, right? So we get to pay per second. Actually, Azure is per second. I think AWS is per hour. So we have to make sure that we are only paying for resources that we need. Security is basically saying that, obviously, making sure that everything we have in the cloud is secure from every threat or whatever it has to be. So we'll just go over reliability. So when we're talking about reliability, it's more of we're talking about business continuity and disaster recovery. When we're talking about availability or reliability, we have to talk about fault tolerance, right? So fault tolerance means if there's a minor fault, we can actually continue our operations. So in that sense, it's stating that we have to have a system doing the same thing. So 2 or more systems doing the same thing, right? So I should start again afresh. Okay, let me just see how many people are there right now. So we have 8 participants. Okay, so I'll just go through what I went through again. Since sorry guys for the people that have heard me, so I'll just go through it again. So today we'll be talking about load balancers. Okay, my name is Adeojo Gboyega. I'm a cloud security architect with Morgan Stanley. I'm based in Winnipeg, Manitoba, in Canada, actually. So we're going to be talking about load balancers. We'll be talking about the 4 main design principles of a load of architecture, what a traditional load balancer is. Then we go into load balancers in Azure. We have 4 different load balancers in Azure, so we have to decide based on students' requirement for what load balancers we're going to choose. Then we have to go through the lab. Then I'll just walk you through 2 VMs and how to configure a load balancer. So let's go to the second slide. So the second, okay, let me just make this big enough for people using their phone. So design principles fundamentals. So when we're talking about designing probably on premises or in the cloud, we are looking into 4 design principles. So we are saying that everything we want to build has to be scalable. It has to be reliable, it has to be efficient, it has to be secure. So scalability just means saying we are adding more resources when we need it, right? Reliability is saying that, okay, if something happens, we are making sure that we can actually continue our business. Efficiency is stating that we are only paying for what we need and not more. The reason why that is because traditionally, so I'll be saying traditionally and on premises just to make sure that you understand that this is talking about in your environment physically. So in your data centers or physically, we have to deal with capital expenditure, right? So we have to plan ahead how much is going to be this server, how much is going to be this license, right? But in the cloud, everything is done for us. All we need to do is just pick what service we want. And with that, Azure, AWS, Google, whichever cloud provider you use, they charge per second, per minute, or per hour. Actually, Azure charges per second, right? I think AWS is per hour. I'm not too sure. Security is just making sure that everything we're doing from an architectural point of view is actually secure so that personal identification, personal identity information, PIIs are not leaked. So we'll just go to reliability because that's where load balancers is under, right? So it says solutions should be available to serve their purposes and end users are recoverable in the event of a failure or disaster. So this is where BCDR comes in. So we're talking about business continuity and disaster recovery. People do tend to merge them together. Yes, you can merge them together, but they are separate. So business continuity is basically stating that if something happens, we should be able to continue, right? Then probably fix it, but we don't want to go out of business because of, let's say, a firewall goes down, right? So recoverability means that, okay, the disaster has happened, right? So the disaster has happened, so we have to recover from what is happening. So under availability, we have things like load balancers. So when we're talking about a load balancer, we're making sure that we have two things. So if you want to load balance something, you can load balance just one entity, right? It has to be two or more, right? So when we're load balancing something, we have let's say two servers. They have to be serving the same purpose. So let's say you have an application. So let's say it's Jumia, right? You have a website, right, that talks to your backend, which is a database, right? When we want to load balance, we cannot load balance the web server and the database server. We have to load balance the web server. So we have two instances of a web server and we have two instances of a database server. So let's say one database server goes down, then the second the second web server can come up, right? So that's a load balancer. That's why we actually have something like a UPS system. So we have a primary power system. If something happens, we can just kick up with our UPS, then we try to figure out what the power is. Recoverability just has to do with backup. That's saying restore services after a disaster. So like after a flood, obviously everything is gone, right? So we have to recover from backup and probably if we have a redundant site, that has to do with like hot site, cold site. But that's not what we're talking about today. We're talking about load balancers. So I'll just skip through to the next slide. So now we have load balancers, right? So load balancers provide the ability to distribute traffic among multiple resources, helping supply availability. We already talked about that. So there are three main algorithms that the load balancer works on. The first one is round robin, the second one is least connection, and the third one is IP hash. So round robin just states that. So let's say we have we have VM1, we have VM2, we have VM3. So let's say Toby goes to my website. The load balancer is going to make it sequential. So Toby is going to go to load balancer 1. So let's say Tinuke wants to check the same website. The load balancer is going to take Tinuke to load balancer 2. Let's say Femi goes to the same site. The load balancer is going to take him to VM3, right? So he goes from 1, 2, 3, 4, then goes to 1, 2, 3, 4, or depending on how many load balancers we have. List connection just states that the connection or the load the end server or like the endpoint with the least connection. So let's say we have VM1, VM2, VM3 again. So let's say we have Tinuke, Femi, and Tosin on load balancer 1, right? When another traffic comes into the load balancer, it looks at the endpoint, which are those 3 VMs, and just states which one doesn't have enough requests. So it just sends it to VM2 because obviously VM1 already has like 3 people on it. So that's basically what this connection means. IP hash is saying that it's something like a sticky session, right? So we are saying when Tinuke comes in to the load balancer and goes through the endpoint, which is the web server or the database server, whichever one we're talking about, it's going to take our IP address and just hash it, right? So next time she comes into that website, she's going to go straight to that same VM that serviced her the first time. So let's say she comes to VM1 the first time she comes, right? So what that thing is going to do is the load balancer is going to take a hash of a client IP and it can do it on the protocol also. So let's say she comes back next week. Instead of her going through the round robin or the list connection, the load balancer is going to see that, oh, we already hashed a client IP and just send that straight to VM1. So that's all about traditional load balancers. Yeah, so we're going to go to load balancers in Azure, right? But before we go to load balancers in Azure, I want to explain what regional and global is, right? So I'll just leave this point. I'll just, can you guys see my screen? Just say yes in the chat, just want to be sure.
We can see your screen.
All right, so.
Okay, there was an issue. You were not presenting. Okay, it's fine, we can see your screen.
Okay, so you can see my screen. That's fine. So we have something we call regions and global, right? And we have something we call availability zones in Azure. Okay, now I'll just explain it, right? So what a region means is, so we're going to take a region as Lagos. A region is basically a location, right? So we say Lagos is a region, and we have another region as, let's say, Ibadan, right? We have Kaduna as another region, right? When we're talking about global, we're talking about Canada, we're talking about US, we're talking about Dubai, we're talking about Iraq, Iran, right? There's something we call availability zone. An availability zone is basically a location in your region, right? So we have global, right? Then we have a region inside a global, right? Then we have an availability zone inside a region. So that's basically what it is. So we can have three regions, up to two or three availability zones in a region. So let's say we have Ibadan, we have Lagos, and we have Osun State, right? We can have an availability zone. We can have three availability zone in Lagos, right? And what's an availability zone? An availability zone is just a location. So an availability zone is basically like Lekki in Lagos, right? So if we have an availability zone in Lekki, that's where the data centers are. So we will now have three different data centers in Lekki, right? Then there's something we call so the difference between regions to region is, and the distance between a region and another region has to be about 300 meters, right? Not meters, 300 miles, right? So if we calculate 300 miles, that's basically like Lagos to maybe Kaduna. So why that is basically because if something happens to a region, let's say a flood happens to a region, it's not going to affect the other region. So that's basically what a global, a regional, and an availability zone is. So we have four different types of load balancers in Azure. I'll go from bottom to top. So the first one is an Azure load balancer, which we're talking about today. So what an Azure load balancer is, it is regional, right? So if you want to implement a load balancer, it's going to be only available in that region, right? You cannot use a load balancer for two different regions. So you cannot have a load balancer that works for um, Ibadan and Lagos together, right? So that's when we're talking about Azure Load Balancer, it has to be non-HTTP traffic. So it's a layer 3 and a layer 4, right? So that's working on TCP. I don't know if does anybody have networking knowledge? If you have, let me know. If you don't have, I can just go through what TCP IP is. So it's working on the TCP and the UDP protocol, right? So what that means is all it does is just look at um, your IP address and your port. It doesn't know anything about a website. Um, so anytime we are doing load balancing or we are using the load balancer, we want to make sure that we are not using it for websites. So we are using it for something that doesn't have to do with HTTP traffic, DNS traffic. All it's doing is TCP. It's checking your TCP connection. It's checking your port, right? So when we talk about application gateway, that's when we're talking about a web. We're trying to load balance for web traffic. So it's same region, right? But now this is more application specific. So we can do things like SSL termination, SSL offloading. It's a little bit too security stuff. So I don't want to go into that. Traffic manager is more like a global thing, right? So let's say we're trying to load balance different things from, let's say, Winnipeg. We're trying to load balance something from Nigeria. We're trying to load balance something from Dubai, right? We use a traffic manager to attach everything together, right? And a traffic manager actually works on DNS, right? So you cannot use it to load balance or to check SSL traffic and things like that. That's what a front door is. So basically, a front door and an application gateway, they do the same thing. So the only difference between a front door and an application gateway is a front door is global and an application gateway is regional. So I think you guys already understand what global and regional is. Let's just go into Azure load balancers. Just 1 minute. So yeah, this is just a brief explanation. Azure load balancer is an high performance, ultra low latency layer 4 load balancing service for all UDP TCP protocols. It's built to undo blah 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 blah. Application gateway, and this way we're talking about layer 7 load balancing, used for optimizing traffic, SSL, DNS, traffic gateway, traffic manager, sorry, is for DNS traffic. front door is for the same thing as an application gateway, just that it's global, right? We don't want to talk about those three. We're just looking at load balancers for now. So when we are deciding to choose, so now we already have 4 load balancers, right? So from an architectural point of view, when we're trying to decide what load balancers to use, these are like the 4 main categories. We will look at this tree also, but these are the 4 main categories. When selecting the load balancer option, here are some factors to consider. So what type of traffic are we trying to load balance? Is the HTTP, is the HTTPS? Then if it's those, then we have to go with the front door and an application gateway, right? So if it's global and it's regional, we know that it's depending on these two already again. We have to look at the availability also. So different load balancers have different availability. I can share like a link to Azure to just look at the availability. We don't want to go into that. Another thing that we have to look at when we are designing for load balancing is the cost, right? Because everything is pretty expensive in the cloud. Not expensive, but everything costs, right? So we want to make sure that we are more efficient with what we are doing, right? We don't want to just use an application gateway where we can use a load balancer. The features and the limit is basically stating what can we get from an application gateway that we cannot get from a load balancer. So we will go through this tree real quick. So let's start from here, right? So we have the start. It's saying if you're trying to load balance a web traffic, right? Web traffic. If we say no, we're not load balancing a web traffic. Is it internet facing? And is it an internet facing application? If we say no, then Azure Load Balancer is the best. So if we're load balancing an application that is internet facing, it says yes, right? Is it global or deployed in multiple regions? So if it's global and deployed in multiple regions, yes, we can use a traffic gateway on top of an Azure Load Balancer. So the way it works again is we can layer them, right? We can have a load balancer on top of an application gateway on top of a front door, right? So it's not like when we use a load balancer, we have to use load balancer all through. We can use a load balancer, then we can use an application gateway, then we can use a front door. Everything depends on your architecture. It depends on if your company is globally available or it's just in Nigeria or it's just in Dubai, right? So it says if it's not global, so if you see this, it's a internet facing and it's not global, right? We just use a load balancer. So let's say if it's web traffic you're trying to load balance, if it's internet facing, an application says no, application gateway. Sorry, I think I missed some things here. So if it's global and it's internet facing and HTTPS traffic, if we say no, it's going to determine if we need performance acceleration. So all this depends on the features and the limit, right? So that's all what this is talking about. What features do we get from a front door that we don't get from an application gateway? What features do we get from a traffic manager that we don't get from a load balancer? I can share this notes and you can just check it out. It's just going to take time for us to go through all of those. And Azure Load Balancer, yeah, provide, distribute, blah, blah, blah. So now we are entering Azure Load Balancers, right? So it provides the ability to distribute traffic amongst multiple resources, helping high availability and elasticity. So as I said, right, we are trying to load balance something that are things that are the same, right? We don't load balance a web server and a database server. Sorry for that noise. We load balance 2 web servers and 2 database servers. I have a picture at the end that I'll probably show with you. So when we're talking about an Azure load balancers, we have 2 types of load balancers. We have the internal load balancers and we have the external load balancers, right? So an internal load balancer is only available in your tenant. So a tenant is basically in your Azure subscription. So what that means is anybody from the internet doesn't have access to it. It's only internal. So let's say I'll show you a picture very soon. An external load balancers are what we use for probably an application. We want to make sure that, oh, there's a typo here. I actually didn't see it, but it's just an external. So what an external load balancer has is it has a public IP. An internal load balancer doesn't need a public IP, right? Because it's internal. An external load balancer, on the other hand, are accessible over the internet. Let me just go through a picture for you. Yeah, so we have this. These are like 2 different scenarios, right? So we have an internal load balancers, right? We have a 2-tier application, we have a web tier application, and we have a business tier, right? So if we're looking for if your load balance is something from the internet, it has to be a public load balancers, right? So if we want to load balance this VMs to these other VMs, it has to be internal. We don't need a public IP for it. So those are scenarios where you probably use public load balancers and private load balancer. So other things about load balancer is it's the same thing, layer 4 traffic. So session affinity is basically what I already talked about when we're talking about the load balancers algorithm. So it's saying that anytime somebody comes in, just cache or hash their, I'm sorry, not hash, cache their client IP and protocol so that next time they come here, the same VM that serviced them is the same VM that's going to service them. So we have different SKUs. SKU is just basically stating, I think it's stock keeping unit. We have the basic and we have the standard, right? For production, you probably would never use a basic. It has to be a standard load balancer. So the difference, I just put just to understand the difference between a basic and a standard. So when we're doing the labs, you just have an overview of what we're doing. So a basic load balancer is not zone redundant, right? So let's say um, we have applications in Lekki, we have applications in Bagada, right? When let's say a flood actually happens in Bagada, right? Because it's a basic load balancer, it's not going to actually rebuild itself in the sorry. So okay, let's start again. I actually zoned out. So we have a load balancer that is built, a basic load balancer that is built in Lekki. We have another one that is built in Bagada, right? So let's say a flood happens in Lekki. Normally, if it's zone redundant, if it's a standard load balancer, it's going to rebuild itself in the Bagada's region, right? But because it's not zone redundant, once a flood happens, we would have to rebuild every single thing. A standard load balancer, it supports zone redundancy. The second one is when we're trying to test health probes, we'll go through what an health probe is in the next slide, I guess. So we can actually just test health probes on HTTP and TCP, right? On a standard, we can test on HTTPS, HTTP, and TCP. On a basic, there's something we call an availability set. That's another topic for another day. It's huge, not that huge, but a basic actually just supports an availability set, but a standard can support a normal VM. So VM means just normal virtual machines. Availability set, it can support the same thing with a basic. VM scale set, that's VMSS, is basically the auto scaling in Azure, some similar to auto scaling in AWS. Yes, so when we are starting to configure a load balancer in Azure, I copied this picture from the internet. So we have 4 different things we are going to have to configure, right? So the front end IP is the IP of the load balancer. As we said, a load balancer can either be a private load balancer or a public, right? So if it's a private IP, then the front end IP is going to be something like a 192.168, sorry, 192.168 dot whatever it is. If it's a public IP, it's going to be like 54 dots. It's just the normal IP address ranges for private and public. Health probe, so it's used to determine, it's for determining whether the destination instance is available to traffic or not. So what an health probe does is it sends packets to our backend. So let's look at this. I think I have a picture. Yes. Okay. So let's say we have traffic coming in right here. We have traffic coming in right here, right? So let's say it's from the load balancer, right? We set up our health probe on the load balancer that says check every VM every probably 5 seconds and let us know if it's healthy. If it's not healthy, mark it as unavailable so we don't send traffic into this VM. Then we just redirect the other traffics to the 2 other VMs, right? So that's what an health probe is saying or is talking about. A backend pool is just stating the VMs in our backend pool. So if you can see it right here. So let's say we have 3 VMs in our web server. That's our backend pool. So a load balancing rule just combines everything. So it combines our front end to our health probe to like a backend pool. So we can have several different front ends. We can have several different health probes. We can have several different backend pools. Then we just have to combine them with the load balancing rule. Inbound NAT rule, I think it's going to be better for me to show you that in the practice. It's just providing ability to map inbound traffic. If you don't understand nothing, it's going to be actually difficult for you to understand this, right? But we'll just go through it in the lab section, so you'll probably understand it. This is just normal load balancing. So it's saying load balances your solutions with public accesses, allows access, private load balancer, availability zone, traffic. You can just take a minute to look into what everything does right here. Then we'll just go to the next slide. Then we'll just start our practice section. So I think, is everybody okay with that? Do you need to take a minute to look into that again? You can just say yes. Can everybody still see my screen?
Yes, we can. We can.
Okay, so yeah, so lab time, right? So it's lab time. So what we're going to do is we're going to create 2 VMs. We can actually create 3, depending on the timing. We're going to create a virtual network. We're going to create a subnet. We're going to create a network security group, and we're going to create a load balancer, right? I'll go through what virtual network is. Then we'll just go from there. So I'll just exit out of this. Just let me know if you can still see it. I've exited. So let me just pull up my paint. Then just explain what a virtual network is. So, okay, so you can still see my screen. So when we're talking about virtual network, it's logical, right? So in your environment, you have your environment that says, oh, this is the IPs we have, right? It's the same thing in Azure. So we have IPs in Azure, and we have a virtual network. So let's I'm not good with this pen stuff. So let's just draw something like this, right? So this is our VNet, right? So this is what we call the VNet. This is where we have to build everything in Azure in. Everything in Azure has to be in a VNet. Not everything, depending on the services. When we're talking about PaaS services, it doesn't need to be in a VNet. Yeah, not. So let's say we have a VNet, so a virtual network, right? So let's say this virtual network is, let's say it's a 192.168.1.0/16 or /24, right? Inside of VNet, right, we have subnets. So we can have 5 different subnets. We can have 2. We can have 1, depending, right? So inside of VNet, we have different subnets. So we can have subnet 1, subnet 2. So inside this subnet, we can create, let's say, a 192.1.9. Damn, I'm not good with this 10. So let's say we have 192.168.100.0/24. This one can be 192.168.120.0/24. And same goes for that, right? So in this case, we have to build our VM. Our VM has to be attached into a subnet that is attached to a virtual network, right? When we're talking about network security group, as I said right here, right, we're going to build a network security group. A network security group is just basically like a layer 4 firewall, right? All it does is check inbound traffic. So traffic coming into our system or traffic going out. That's inbound and outbound, or ingress and egress, whichever one makes sense to you. So we are going to attach a network security group. It can be attached to a subnet or to a NIC. So a network interface card to a VM, right? So that's just basically what the architectural point of view is. I just wanted to get that out of the way. So let's just go through the diagram for our architecture right now. So this is the VNet right here. So you can see this VNet, right? Then this web tier is a subnet, right? That's where we have our VMs. Then we have the network security group. It's not shown in this place because we are not talking about network security group. Then we attach our load balancers. So does everybody understand the whole architecture of what I want to build in Azure right now, right? If everybody understands, you can just give me a yes in the chat. Then we can just go from there. Let me just see the chat right now real quick. I'm sorry, I got to leave now. Thanks for trying to send. Yeah, no problem now, Latif. That's fine. So we have. Okay, so we are going to build 2 VMs, right? We're going to build a subnet. We're going to build a virtual network. So let's go. So there's something we call the resource groups in Azure, right? That is just a logical container, right? So you can have your resource group is stating that everything you want to build must have to be in it. So a resource group is basically like a folder. So we are building everything into a folder just to give us more structure. You can actually build anything up outside the resource group, to be sincere. So I already made one for like Threaten Academy, right? So let's just go close that one right now. So I already built the virtual network, but I'll just go through it with you. I built one VM, but we'll go through the second VM, but 2 other VMs, right? So this is the Threaten VNet, right? So if we want to build a VNet, we can just click add right here, or we can go to all services right here, or we can say create a resource. There are different ways to create a resource. So let's just type virtual network. I'm not going to build this VNet. I just want to show you how to build a virtual network. So we click on add over here. So it's saying, obviously, we have to have built a resource group. If you've not built a resource group, it gives you the ability to build it from here. So, but I already have one. So I'll choose Threaten Academy. Again, resource group is just a logical container for everything we want to build. So let's call this virtual network. Let's say Threaten VNet -02, right? A region, right? Can you see? Unfortunately, there's no Azure. We don't have regions in Nigeria. You can see West US. You can see South African North. So this is just where this metadata is going to be built in, right? So we go to next. It says IP. So this is where we try to design our address space. So we can say we want to be a 192.168.0.0/16. No, I didn't put a //16, right? So under this, so it's saying it overlaps, right? So let me say 167. So this is /16, right? We now have to build a subnet. We can build a subnet separately, but it's better to just build it right there. So we can say we can build different subnets. That's what I said. We can build 10, 15, depending on our address space. So let's say I say first subnet. We can name our subnet as first subnet, and we can give it. It has to be in the range of our virtual network. So it's 192.168.167. So now we can take it from 0 to 255. So I can say 250.0/24, right? So it's looking at the slash. Then we can just click add. Security, we don't need to worry about anything here. So tags, I have some tags just for normal stuff. Then we just review and create. Then it creates our virtual network. So that's how I have this one right here. So if you look at this virtual network, this is the address space I selected, and this is the subnet, right? I only created one subnet, 100-0. So we've created our subnet. Let me go back to our resource groups. So we created our subnet. So let's go through creating a virtual machine. Okay, so we just type virtual machines. We click add a virtual machine. So we have to add it to a resource group every single time. Let's say Threaten-VM-02, right? So Canada region, obviously I'm in Canada, right? So I'll just click Canada Central availability option. So we can say availability zone. That's when I said we have like 3 data centers in one availability zone. So you can pinpoint which data center you want it to be. You don't have to do it if you don't need to. So you can just leave that as that. Then image is stating, if we scroll this, say choose the base operating system. So what do you want this VM that you're building to be on? So we'll just choose a Windows Server 2019 because we can. The size, we're not going to go through spot instances, a separate issue on its own. So a size is saying, so if we select size, we can actually select, depending on the RAM, the data disk, whatever we want. So let's say we want a VM that has 2 CPUs and 8 gigs of RAM. You can see how much it's going to cost us per month to run this, right? So if we're looking for more optimal, so we can add more filters right here. So we can say more sizes, and we can just scroll down. So you can actually see VMs that's 256 gigs. You can see how much it's going to run you every month, right? So it actually depends on what you're building. So we'll just go with this small one. It's okay for our lab today. Then we have to give a server a name, right? So let's say Threaten-02, right? Then we give it a password, another password again, just to be sure. we're not going to create an inbound rule. We'll do that through the network security group. So you see how it works. Disk, we can choose if we want a premium SSD, HDD. This also costs money. So you have to decide which disks you want. I can go with a premium because I'll probably just delete it after the whole thing. So networking, right? So we already built our VNet. We built our subnet, right? So we'll just choose the threatened VNet, then we choose it to be under the subnet inside the virtual network. So we have a public IP. So we have to create a public IP for our virtual network. So if we want to RDP into it, we can just do create new. Then we can just say this. That's okay. We want to be a standard. That's okay for us now. Now we have a network security group. I already created one. We'll look into creating a network security group. I just want to build this because it's going to take time. So we have virtual network, we have a subnet, we have our public IP, we have our network security group, right? So that's okay for the networking part. For the management part, it's just saying we don't have to worry about anything right here. This is a different lesson. It's on boot diagnostics, OS stuff, manage identity. So yeah, auto shutdown. Let's say you forget to shut down your VM, you can just auto shut down. We don't need backup for now. This is actually something new in Azure. It actually just came out a week ago. So it's saying Azure is going to update your patches for you, or you can manually update your patches for you. In an enterprise, you probably just do manual because if you're not careful, if it does an OS patch that doesn't align with your code is probably going to break everything. So you want to make it manual. So next, we have extensions. We have proximity. We don't have to worry about this right now because these are separate lessons on their own. We just want to build a VM right now. I just like to add my department right there. So deployment. So your deployment can be dev, it can be production. So this is basically for cost management. We can also use Stack for automation, but for now, it's just for cost management, just to see which department is spending money. So let's say this is for development, right? So we just review and create. So it goes through just to check if we forgot to put anything. It's going to run a validation check. Then after that, we can just start to create. Just give it a minute to validate. So validation passed, so we can just create. Okay, so let's just leave that for now. Let me duplicate this. So it's building. Let's see, supposed to switch actually. So let's leave that for now. Okay, so we are going to, no, that's not what I want to check. So we have a network security group, right? As I said, it's basically a stateful firewall, but it just knows IPs and it just knows IPs and ports, right? That's all it does. It doesn't know anything about FQDN, so that's fully qualified domain. So let's say we want to block Google, right? We cannot use an NSG to do that. We have to use something like a third-party firewall, let's say Cisco, or we can use the Microsoft Azure. Let's see if this is creating. Okay, so it's creating. So let's say we want to create a basic firewall, right? All we need to do is just put it in a resource group as usual, right? Just give it a name, right? Then it's just build it. Can you see there's nothing really to do until you build it? Then we can now go into what a network security group is. So now I already built one actually. So if you look at this, right? These are the rules that come with a network security group. You cannot delete these rules, right? You can actually just add to them and give them a better priority, right? Obviously, as a normal firewall, it has a deny all exception at the end. So anytime you want to allow a port, you just have to make it a priority that is higher than this deny all rule. Let's see if our VM is, okay, our VM is still creating actually. So I created one VM, so we have a second VM. So we're going to try to create an IIS server, right? So an IIS server is just basically us trying to build a website that says, okay, it's just a test website. It's not anything based. It's not anything superior like that. You'll see the code I'm actually going to use. Let me just go here. So, no, okay. So it's going to be here. No, where did I put that code? I can't actually remember where I put the code. Okay, it's over here, right? So we're just going to copy this stuff and just put it in PowerShell. Then it's going to build just a basic website for us. There's something, okay, so it's built VM, right? So if we look at, this is how the structure of a VM is, right? So if we look at this, we have our public IP, we have every single thing right here. So now we cannot connect to this VM, right? Because it's under this network security group and there is no allow inbound route to port 3389, which is RDP, right? So we now have to create an allow rule. So let's say, let's click on add. I have to check what the IP addresses for these VMs are actually. Just give me 1 minute. Let me just pull up the second VM. I think we are already running out of time. So we have two private IPs. So you can see this is the first private IP, right? So we're going to say any source. So we are coming from the internet, right? Any source, going to any source port. We don't know the source port. Going to a destination. So the destination is basically our VM, right? So we add our destination VM ID. Then we put 3389. We can leave it as any TCP IP. Protocol priority, that's why I said we can leave it as 500. Then we could just name it. So we're saying allow RDP VM1, right? So we can just copy and put that in. So, okay, let me just show you that when we try to connect through RDP, it's not going to connect actually. So let me download the file. Let me try to run it. So if I click connect, it's just going to go like that, right? So, but when I add this rule, I'll be able to connect. It's going to take a little while for it to come back. Okay, so we have to cancel it. Just give it a while. So we have to do the same thing for this one also. We have to create an inbound rule for this one also. It's joined to the same RDP session. So we have to create a separate one for this. So so it's different destination, right? The same 3389. Okay, if you work 3389. So we're going to name this allow RDP VM2, right? We just copy that and paste it here, add, right? So this is just for us to be able to connect to this VM. Let's just download the second one. Let's try. Hopefully this works. Okay, it's still taking time to propagate. Let's make sure that we have everything. Okay, so can you see? Sometimes it just takes time to propagate. So the first one is straight in 01. I think that's the name. So we just give it our password and voila, we're inside. So we just probably just created a VM, right? So I'll log into this, then we'll just build a normal. Can you see my screen on this one? You can let me know if you can see it. So we have this VM right now. Can you see it?
I see your screen.
So you can see that I'm inside the VM, right?
Okay, I'm seeing all I'm seeing is desktop. Okay, now I can see you. Okay.
Okay, so so what we want to do right now is we just copy this PowerShell script that I said. I copied the other time. Really, like, okay, no, it's going to be in my lab tutorial. So we just copy this. Okay, if it's going to work. Copy, then we just open PowerShell right here. I'm not a developer, so this is just a basic one just to test, right? We can use ISC, that's fine. We just copy and it's just going to build us just a basic. Okay, enter, please. Okay, so let's do the same thing for the second VM so we don't waste time. Download. Okay, connect. Okay, different name. So it's going to be 310.02. You're on this down. Okay, connect. So yes, so we have the second one, right? So let's do this, and we have this, right? So this is still building our normal, just our basic website. Okay, we have one chat. Okay, still working on YouTube. Okay, so we just go through the same step. Open PowerShell. You can do it in administrator mode or whatever mode you want to use. Can you see? So we've built the first one. So we just go through with this. Let's click enter. So what this script is saying is install the, okay, it's saying install this IIS role. So IIS is basically a web server in Windows Server, right? Then it's saying remove this, then add this content. So it's saying say hello world from computer name. So the computer name is threaten VM01, right? So if we try to, so that the second one is building, right? So let's say we go to the internet, right? And we just type in the IP address of this VM, right? It's supposed to bring out the 192.168.100.4, right? Can you see it's just a basic website, right? Hello world from Threaten Academy or whatever it is. Then the second one is building. I'll just minimize the second one also, right? So now, what if I want to get through to that VM from the internet? We have to add another rule to our NSG. So basically, our firewall that says allow port 80 because our web server is listening on port 80, right? So we say anything going to our first destination, right, which is 192.168.100.4, right, on port 80, right? Allow it. So this is basically saying allow HTTP. So what that is? Oh no, this is actually priority, right? So this is allow HTTP, right? So now when we create this rule, we can now use the public IP address to get to this VM from the internet. It takes some time to actually propagate. So it might take some few seconds to do that. So I'll just add the same thing for this network security group. So the same thing on port 80, right? That's what we're doing. Destination is going to be IP, is going to be 192.168.100.5. We can give it, we can just give it 700. We don't, doesn't matter, right? So allow HTTP, allow HTTP. Okay, so we can just give one, right? And add. Right, can you see now we can actually get to this VM from the internet, right? So if we try the same thing for VM2, we should be able to get to it in a second. Okay, so it's still propagating. So now let's just go through with our load balancer. Let's let that keep propagating, right? So we have our load balancers. Okay, so that's still propagating. Let's give it time. It's going to propagate. It takes like some few seconds. So we've spoken about resource group, right? We add it to the Threaten Academy. Okay, chat is coming in. Okay, that's never mind. So if we look at, let's try this again. Did I mess up something? Okay, I'll go through with it again just to check. So let's see, allow HTTPS 192, threaten VMS 168. So yes, she works. Just give some time. So let's call this threaten load balancer, right? So the same region, it's going to be public, right? Because we want it to be accessible over the internet. We go to standard. We can create a new public IP address. Let's say threaten load balancer public IP address, right? It's going to be, we can decide when we done that. It doesn't matter, right? So you can just review and create. We don't need to add tags for now. Let's create. Let's see. Okay, now can you see? So VM2, you can actually go through with this. You can try on probably your mobile phone or your laptop to see if you can actually eat this IP from your side. You should be able to. You should be able to. So that's fine actually. So I can give you the second one for the second VM. So this is the second VM, right? So this is it. So you can see we have two VMs, right, acting as a load balancer. So our load balancer is deployed, right? So what I said is the first one. So we have a front end IP, right? So that's the public IP address of a load balancer. We have a backend pool. So our backend pool is going to be these two VMs, right? So we want to load balance traffic on those backend pools. So let's call them backend pool 1, right? Backend pool 1. We have to add them to the VNets that they are in. Then we add VMs, right? So you can see that there is one VM that is not showing. I actually did it because why is that? So you said you can only attach a virtual network that are in the same location and on the same virtual network as the load balancer. Virtual machines must have the same standard public IP. So you see we created a standard load balancer, right? Our public IP address on our VM has to be standard also. So if we go to the networking on our VM1, we go to this, we go to IP, right? We go to this. You can see that this is going to be, it doesn't show that it's a public, we'll just deassociate it for now. So we don't need a public IP address to add it to a load balancer, right? So when that propagates, let's give it some time. It actually takes time to propagate that. 1 minute, hopefully. 1 minute, 1 minute. We already allowed everything. So has anybody tried any of these IPs? Can they hit it from their end? Just let me know if you can actually hit that public IP address. Again, it's 40, 82, 181, 132, 20, 151, blah, blah, blah. Yeah. It's taking time. Just give it a minute. It's going to propagate. So what we're trying to do is stating that, yes, my load balancer. Yes. So it's saying when we want to add, we cannot add a basic public IP to a standard load balancers that uses a standard public IP address, right? It has to be standard or basic. Those are some of the caveats we have with when we're trying to architecture for a load balancer. Yeah, this thing takes time. I just wanted to show you that scenario so that anytime you're actually doing it in your lab and you actually forget to use a standard IP address on your VM, you can actually troubleshoot it. Please, actually, yeah, just be fast. Just give it another minute. It actually takes time to propagate. This is taking so long. But we have to wait for it. Another 1 minute, hopefully. Okay. Okay. Now this is taking too long. Just give it a minute. It actually takes this long, actually, for some reason. Because what they're doing is basically deassociating it from like the VNet, deassociating it from like the subnet, all those kind of stuff. And it's software defined, right? So it's basically just running some script in the backend that we don't know of or we don't actually care about. Okay. Let's try this and see if we can actually see it. If you have any questions, I can actually answer it for now. Actually, how do I get where to practice this? Okay, so you can actually sign up for Azure. So let's say portal.azure.com, right? Oh, okay, it's going to actually take me to my own portal. Sorry. So let's say free Azure portal. Let's try it. Yeah, free Azure account, right? So you can just go to this site and you just put in your credit card. It's not going to take anything from you. So it just gives you a free $200 or 260. That's because it's Canadian, right? It's going to give you a free $200 for the first 30 days to practice. So you just sign up. So you can just click start free. Let me just go through. You click start free, then you just go through the process of signing up. That's it. You can just type Azure sign up. Okay, now it's the associated, right? So let's close out of this and let's add a VM. Okay, so we have to go back actually. So we add a VM. Okay, let's just do treating backend pool, right? We are running out of time, but can you see now it shows the two VMs, right? So we just click add, then skill set is asked it's another topic we're not doing that right now, right? Hopefully this adds quickly also. So we've added, so let's go to the diagram again. VM, right? So if we go to this diagram, right? So it's saying we've added our front-end IP, we've added our back-end IP. Now we have to do our health probe, then we now connect it together. So that's what we are doing right now. So it's still adding the back-end pool. So what this is actually doing is actually changing the network configuration on our VMs, right? So now you can see normally our VMs is having this public IP, right? So when everything is attached to the load balancer, all you'll be seeing on the VMs is going to be the public IP of the load balancer. I'll show you right now. When it finishes, you can just note this public IP 40.181.132, right? So when it finishes, all you'll be seeing is basically the public IP of the load balancer because it's changed the networking. because we are going through the load balancer. All these things always take time. Let's go to this VM. So you can see this is the 20.39, right? But when it adds, let's do a refresh. Okay, so that's added. I think I have to join everything together first. Okay, when does it change? Okay, so let's just attach. Okay, so let's go to our L probe. We'll see that after this. So what the L probe is saying is, okay, just check on this protocol, on this port, because this is the port we are listening on, and every 5-10 seconds, ping the backends to make sure that they are healthy. If after 5 seconds it is not healthy, then it's going to mark it as unavailable. So this threshold states that if we ping it the first time, we ping it the second time, that's 10 seconds, right? If it doesn't respond back to the load balancer, then we are going to mark it as unavailable so that we don't send traffic to that load balancer. So that's what the health probe is saying. So now the load balancing rule, this is where we attach every single thing, right? So let's just call LB rule, rule 01, right? So IPv4. So you can see we already have our front-end IP. TCP, the load balancer is listening on port 80. Our backend is listening on port 80. We already created our backend pool, the same probe, right? Session persistence, this is what we're talking about, right? For a load balancer that is a level 4, layer 4, you can only do session persistence on client MPI protocol, as we spoke about. TCP reset, we don't need that. Floating IP, this has to do with SQL always on availability group. This is a different case on its own. We don't have to worry about this. We just click OK. We just wait for that to show up. So yeah, the rule has happened. So we just refresh, right? Let's see if this has actually changed our IP on our VMs. This should have changed. For some reason, it's not changing, right? Okay, so let's see what's the front end IP. Oh, it's actually changed. Can you see? VM2 is 20.39.140. VM1 20.39.140. If we look at our front end, our load balancer, right, we have 20.39.140, right? So if we want to get to, so if we do this, it's probably not going to work. It's because it's cached it, right? That's why it's still doing. So let's do, let's copy our IP for our load balancer. Let's open Tor browser. I just want to make sure that it's not, I like to use Tor browser just for, okay. So it's just going to start up. Then let's just make this. Then this is the IP address of my load balancer, right? Let's see what's going to happen. Can you see? Now it takes me to VM2, right? I can keep refreshing. Sometimes it caches the IP, the IP for some seconds. So if you can try this IP also on your side, I'll try it on Mozilla, right? It should give us separate, hopefully, a separate VM. So we should be able to hit a separate VM. Still VM02. Okay, so we can actually test to see what is happening, right? So we have an health probe. So let's say we disconnect. Let's say we disconnect this VM. So let's stop it, right? Okay, no, because we are actually seeing it from VM2. Let's stop VM2, right? So let's stop VM2. Just give it a bit of a second. You're going to see it over here on the right-hand side. Just okay, I think we have some chats. Just give me 1 minute. Okay. Tell them that you can check our website, threaten. Okay, I'll do that. Okay, so we have I just want to show you that once we stop this VM, it's going to send us to VM1 right away. It's still deallocating. You can see the status right now. All right. Let's give it a minute. All this actually takes some few seconds to propagate. I doubt we'll be able to go into the load balancing inbound NAT rules and the outbound NAT rules. Those are the other parts, but we can always do that some other time. You can actually also check the Threatening Academy website if you need more information about the Azure program. Okay, so now this is stopped, right? So let's try using Mozilla right now. So we've used, so let's try using Mozilla. Let's see what it's going to send to us, right? Why does this keep opening this? So it's going to click enter. Can you see it takes us to VM1, right? It's going to keep taking us to VM1 because VM2 is down. let's start it back up, right? That's fine. Let's start it back up. So a load balancer, right? So now you can say, oh, Gboyega, but how am I going to keep on going through this public IP address? That this is actually not practical, right? Because you are not going to remember the public IP address. So what you can do is you can actually add a DNS to your public IP address. So let's click on the public IP address for the load balancer, or we can just go through the resource group actually. So I just want to show you how to add a DNS solution to you, and we'll just wrap up. So let's say we have Trading Academy. Let's go to just quick one. We have to be fast, right? Yeah, I'm already taking you guys' time. So we have load balancer, right? So now you can see there's no DNS attached, right? Let's go to configurations. We can attach, let's say, trading, right? And just click enter. This is not allowing me to save. Okay, trading, right? We just save it. Then when we save it, just give it some time. Okay, save, please. So it's saving the DNS name for the public IP address. So let's refresh. It's supposed to show right here. So all this thing actually takes time. So now, right? So if I do this, if I go right here, I click here, it's going to take me to the VM, right? But obviously that's not practical because it's a public, it's an IP address. So if I go to, where did I open it? If I go to here and I copy the DNS name, we can actually just copy this and voila, can you see? It's already now using the DNS for your load balancer. Another thing we can actually do is if you have a domain manager, right, like GoDaddy, right? Let me see. I think I have a GoDaddy. Let's see if that works. If we have a this actually takes time to propagate, so we might not be able to see it, right? So where do you see? This in my account. So I have a GoDaddy account. I just want to show you how to attach. So you see we are using Trading Academy to get to the load balancer. We can actually have a name. So we just create a C name. Hopefully you guys know a C name. Then say www points to this, right? So that's add. It takes time to propagate. So what we're going to be eating right now is we're going to say www.Gboyega Adeojo. I think I missed another a.ca. Yeah, it's going to take time to propagate this actually. So DNS takes time to propagate, but if it's possible, we will have seen it. But I think that's all for now for the load balancers. If you have any questions, I can actually quickly answer them before we end this webinar. Does anybody have any questions on the load balancer? Whatever questions you have, I should be able to answer you. Anybody? Nobody? I'll just give you like a 1 minute to ask me some questions. If you have any questions, I can definitely answer that. Hey, it's taking time to propagate this actually, but that's how you add a DNS to your load balancer. Okay, so if anybody doesn't have a question, I hope this has been very informative for you guys. You can just check again. Chatting like, okay, I think one chat came in. What's that? So everyone is good. Is that correct, Azuka? Okay, so thank you very much. If you have any questions, you can just reach out to, I think, Trading Academy. You can reach out to me also. I can actually answer some of your questions. But yes, thank you very much for joining me. Then probably some other time we'll probably.
Sorry, I think
okay, go ahead.
Where is raising his hands up? Can unmute.
Okay, I'm very bad at using Zoom, so you would have to bear with me on this. I don't think I can do that. Can you unmute yourself? Can you help me unmute him? You're the host actually. So I don't think I can unmute him from my end. Okay, I can. Yeah, but it's actually the stuff is lagging. If you can type your questions in the chat, I can definitely answer you. Okay, wait. Yeah, it's taking a lot of time to actually propagate this DNS, but that's how you actually attach whatever you need to. Apoy, do you have any questions? Oh, it's not still propagating yet. So no questions, right? Okay, so thank you very much for being with us. Hopefully you have a great day. I'm just starting my morning, so you have a great day, guys. Bye bye.